So pardon me for the delay because of the internet fluctuation. I could not start on time. So let's begin. Okay, so first and foremost, in today's class I will basically discuss about limit and continuity of function of two variables. So the date and time is not match with this slide because these are some old slide which I am using. So see, first problem is question. So first question is, does knowing that 1 minus x square y square by 3 less than or equal to tan inverse xy by xy less than 1 tells you something about limit xy tends to 0 0 tan inverse xy by xy. So the question is basically, so in the tan inverse xy by xy, so this is basically you have a function. So what kind of function? If you consider u equal to xy, then you will get that tan inverse u by u. So this will give you, if you try to put u equal to 0, then you will get tan inverse u by u. So that will give you 0 by 0 form, right? But if you here basically it is a this problem is a generalization of squeeze theorem. So what does squeeze theorem tells? Squeeze theorem tells that if you have three functions fx, gx and hx, and fx is less than gx and gx is less than hx, then if as x tends to some alpha, if fx and hx converges to the same value, then gx also converges to the same limit. So the same thing we will apply here. Does knowing that 1 minus x square y square by 3 less than tan inverse xy by xy less than 1 tells you something about limit xy tends to 0 0 tan inverse xy by xy. So now first and foremost, 1 minus x square y square by 3, this is less than tan inverse xy by xy, this is less than 1. So now if you take x and y both converging to both tending towards 0 0, then what will happen to this left side? This left side will become 1 minus x square y square by 3. So 1 minus 0 square into 0 square by 3. So 1 minus 0 is 0, and then less than tan inverse xy tends to 0 0 tan inverse xy by xy less than, again the right hand entity is a constant. So xy tends to 0 0 will give you 1, that means 1 will remain 1. So that means that the left side and the right side of the function tan inverse xy by xy, both of them are converging to the same limit. Now if both of these functions are converging to the same limit, that means the middle person, that middle guy, tan inverse xy by xy, that will also converge to that same limit. So as xy tends to 0 0, 1 minus x square y square by 3 tends to 1. So and the right hand entity is 1 is always remaining to 1. So by squeeze theorem or sandwich theorem, tan inverse xy by xy also converging towards 1. Next problem. Does knowing that 2 into modulus of xy minus x square y square by 6 less than 4 minus 4 of cos square root of mod xy less than 2 mod xy tells you anything about limit xy tends to 0 0 4 minus 4 cos square root of mod of xy by mod xy. Now again same thing. What you have to do, you have again fx, gx, hx, you need to identify fx, gx, hx. Now here is a bit tricky part. What is that tricky part? The tricky part is, so what is the tricky part? So 2 mod of xy minus x square y square by 6 less than 4 minus 4 cos square root of mod xy less than 2 mod xy. If you divide it by mod xy, so then your left hand side will become 2 minus mod xy by 6 less than 4 minus 4 cos square root of mod xy divided by mod xy, this is less than 2. So now as x and y tends to 0 0, the left hand side, this left hand side tends to 0, tends to 2 because xy mod xy will go to 0. So 2 minus mod xy by 6 will go to 2. So by squeeze theorem again, by implementing squeeze theorem again, 4 minus 4 square root of mod xy by mod xy, this will converge to 2 as xy tends to 0 0. So this is how we have solved our problem 2. Next problem, find the limit if it exists or show that the limit doesn't exist. So pardon me for this extra s, this should be doesn't exist. Okay, exist. So limit xy tends to 0 0 y square by x square plus y square. So now consider, so for limit to exist, if you want to prove that limit exists, then you need to use epsilon delta problem. I will just go through for quickly that what is epsilon delta in case of limit. Okay, so I will just discuss what is epsilon delta limit. Epsilon delta in case of two variable limit. Epsilon delta definitions of limit. See, so the formal epsilon delta definition for a function of two variables states that limit xy tends to ab, this fxy is equals to L. If for every epsilon tends to 0 greater than 0, there exists a delta greater than 0 such that if 0 less than square root of x minus a whole square plus y minus b whole square, this is less than delta, then modulus of fxy minus L, this is less than epsilon. So this is your the formal definition of epsilon delta. And then if you want to show that such a limit exists, you need to show so now if you want to show that okay limit exists, then you need to show by this proper definition. You cannot show by showing an example. Okay, but okay, I will come extra some problems. PDF problems and solutions. Limit continuity of functions of two variables. PDF. There may be some extra problems. Okay, so limit of a function of two variables, let f be a function of two variables x and y, the limit of fxy as xy approaches ab as L, if limit xy tends to ab, fxy becomes L. And what is the epsilon delta definition? If for each epsilon greater than 0 there exists a small enough delta greater than 0, both are positive, such that for all points xy in a delta disk around a comma b except possibly for a comma b itself, the value of fxy is no more than epsilon away from L. Using symbols you can write it, for any epsilon greater than 0 there exists a number, a positive number delta greater than 0 such that modulus of fxy minus L, this is less than y epsilon, whenever 0 less than square root of x minus a whole square plus y minus b whole square, this is less than delta. Now come here, so find the limit if it exists or show that limit does not exist. So limit xy tends to 0 0 y square by x square plus y square, you consider the path, जैसे how to show that the limit does not exist for R. So in case of real line R, you calculate left hand limit and right hand limit. If left hand limit and right hand limit both of them does not exist and they are not same, then we say the limit does not exist. So here in two dimension plane there is an infinitely many possibilities. So you need to show this, you need to find at least one path. For that path you need to show that okay, limit does not exist, then you can say the limit does not exist. But for to show that limit exists, you need to verify using epsilon delta. There is one problem here where limit does not exist. You can show using epsilon delta, that will be your home task. So now for this problem, limit xy tends to 0 0 y square by x square plus y square. So now fxy equal to y square by x square plus y square, let y equal to mx and your m not equals to 0. Your y equal to mx and your m not equals to 0, that means mx tends to 0 as x tends to 0. Let fxy equal to m square by 1 plus m square now, because if you put y equal to mx, your mx tends to 0, that means x tends to 0, but x tends to 0 does not imply that x is equal to 0. So fxy becomes actually m square by 1 plus m square. So if xy, the limit that actually dependent on m and hence not unique, because if you need to show that if limit exists, this limit must be unique. So if limit is not unique, that means limit does not exist. Since your fxy is depending upon m, that means your limit does not exist because your limit is dependent upon m. Hence xy tends to 0 0, fxy does not exist. Is it clear? Is it clear? Okay. Next problem is fxy is 3x square y by x square plus y square. Now x square by x square plus y square, this is always greater than 0 but less than or equal to, this is x square by x square plus y square, this is less than or equal to 1. So 0 is less than or equal to 3x square y by x square plus y square less than or equal to 3y. So for xy greater than or equal to 0, so by squeeze theorem xy tends to 0 0, your fxy becomes equal to 0, and for the other case you can just alter the inequality to get your answer. Next problem, fxyz equal to e ki power y square tan xz. Now fxyz equal to e ki power y square tan xz. So as xyz tends to pi 0 1 by 3, so your f of xyz becomes e ki power 0 square tan of pi by 3 equal to, so e ki power 0 square is 1 and tan pi by 3 equal to root 3. Okay. Next problem. Using epsilon delta definition, prove that following function fxy are continuous at a point 0, 0. So your fxy, this is equal to x square plus y square, and your fxy equal to x plus y by x square plus 1, and your next is fxy equal to tan square x plus tan square y. So again I am recapitulating you that for any epsilon greater than 0, you need to show that there exists a delta. Obviously delta will depend upon this epsilon. So this number delta greater than 0, this exists, this delta greater than 0, this exists, such that modulus of fxy minus L, this is less than epsilon, whenever 0 less than square root of x minus a whole square plus y minus b whole square, this is less than delta. So limit laws for functions of two variables. If fxy and gxy are defined for all xy not equals to a comma b in a neighborhood around a comma b, and assume the neighborhood is contained completely inside the domain of f, assume that L and M are real numbers such that limit fxy equal to L and limit xy a comma b gxy equal to M, and let c be any constant, then each of the following statements hold. That means it is a constant then xy tends to 0 0, c will be c itself. Limit xy tends to a comma b, x will be a. Limit xy tends to a comma b, y will be b. Sum law holds, that means limit xy tends to a comma b, fxy plus gxy, that will be L plus m. Difference rule holds, that is limit xy tends to a comma b, fxy minus gxy equal to L minus m. Constant multiple law holds, that means limit xy tends to a comma b, cfxy will be cl. Product law holds, that means limit xy tends to a comma b, fxy into gxy will be lm. Quotient law holds if and only if there that m is not equals to 0, that means limit xy tends to a comma b, fxy by gxy equal to L by m for m not equals to 0. Power law holds for any positive integer. Root law holds for all L if n is odd and positive, and for all L greater than or equal to 0 if n is even and positive. Okay, so this is a algebraic problem. So what does this problem say? Find each of the following limits. Limit xy tends to 2 minus 1, x square minus 2xy plus 3y square minus 4x plus 3y minus 6. So this is basically a quadratic equation. So for this quadratic equation you just put x equal to 2 and y equal to minus 1, you get the answer. So it is a easy question, I will not discuss much time on it. So you just check by on your own, it will be minus 6. Till now it is enough from this note. Let's return to our note. Using epsilon delta definition, prove that following functions fxy are continuous at a point 0, 0, fxy equal to x square plus y square, fxy equal to x plus y by x square plus 1 by tan square x plus tan square y. Solution 4a. fxy equal to x square plus y square, f00 equal to 0 square plus 0 square equal to 0, fxy minus f00 equal to x square plus y square minus 0 equal to x square plus y square equal to mod of x square plus y square. So first we need to show fxy minus f00. Is it a continuity problem? Okay, then I need to discuss the continuity. So continuity of a function of two variables. A function fxy is continuous at a point a comma b in its domain if the following condition satisfied. Fab exists, the limit exists, and the xy tends to ab, xy equal to fab. So here you just, for epsilon delta definition of continuity, what you need to know for epsilon delta continuity, for any epsilon greater than 0 such that there exists a number delta greater than 0 such that f of xy minus f of a comma b is less than epsilon whenever square root of x minus a whole square plus y minus b whole square less than delta. If this condition is satisfied, we say limit x comma y tends to a comma b fxy equal to f of ab. C. Examine whether the function x square plus 4y when xy not equals to 1 2 and this is equal to 0 when xy equal to 1 2 has a limit as x tends to 1 y tends to 2 or is continuous at 1 comma 2. The first problem is limit exists. You can show by epsilon delta, but it will not be continuous because you can show that the limit is not matching with 0, but we need to show using epsilon delta definition. Okay, now we can proceed here. Fxy equal to x square plus y square and f00 equal to then becomes 0 square plus 0 square equal to 0. Fxy minus f00 becomes x square plus y square minus 0. This becomes x square modulus of x square plus y square equal to x square plus y square. Now say epsilon greater than 0 given, then set delta equal to square root of epsilon. Note that 0 less than norm of xy minus 0 0. This norm of xy minus 0 0 means square root of x minus Euclidean norm, square root of x minus 0 whole square plus y minus 0 whole square equal to square root of x square plus y square. Thus 0 less than square root of x minus norm of xy minus 0 0 equal to square root of x square plus y square less than delta equal to square root of epsilon equal to x square plus y square less than epsilon. So you get for given epsilon greater than 0, there exists delta, you choose square root of epsilon such that 0 is less than or equal to norm of xy minus 0 0 norm of a minus b. This is less than delta whenever fxy minus f00 is less than epsilon. So I am just holding this proof for a couple of minutes so that you can digest it. Okay, next move to the next problem. Solution of 4b. fxy equal to x plus y by x square plus 1, f00 equal to 0 plus 0 by 0 square plus 1, so f00 is 0. So if mod of fxy minus f00, this is equal to x plus y by x square plus 1 minus 0, this is equal to mod of x plus y by x square plus 1. Now note that x square plus 1, this is greater than or equal to 1, this is equal, this implies that 1 by x square plus 1, this is less than or equal to 1. Now fxy minus f00, this is less than or equal to mod xy. So mod of fxy minus f00, this is less than or equal to mod of x plus y, this is less than or equal to mod of x plus mod of y. Okay, so x square less than delta square, y square less than delta square, so mod of x less than delta and mod of y less than delta, this becomes, this makes mod of x plus mod of y, this is less than 2 delta. So now you set delta equal to epsilon by 2. So then from this 2 you get mod of x plus mod of y. This is less than 2 into epsilon by 2. This becomes epsilon. Hence we get norm of xy minus 0 0. This is less than delta. This will give you mod of fxy minus f00 less than mod x plus mod x plus mod y less than epsilon. I am holding this for a few minutes so that you can cope up with this proof. I will again discuss the next proof in the next class, in the next few minutes. If it is, then I will discuss the next solution of 4c. fxy equal to tan square x plus tan square y, f00 equal to tan square 0 plus tan square 0 equal to 0. So mod of fxy minus f00 equal to tan square x plus tan square y. Tan square x plus tan square y becomes sin square x by cos square x plus sin square y by cos square y. This equals to sin square x by 1 minus sin square x plus sin square y by 1 minus sin square y. Now we will use a simple, very well known result, that is sin square x is always less than x square. Okay, because how? Because sin x equal to, if you use Taylor theorem, so sin x equal to theta, sin x equal to x minus x cube by factorial 3. Now for that reason sin x is always less than x, and that is why sin square x is less than x square. So using sin square x less than x square in 2, we get tan square x plus tan square y. This is less than or equal to x square by 1 minus x square plus y square by 1 minus y square. Now let norm of xy minus 0 0 is less than delta equal to x square plus y square. This less than delta square. So x square less than delta square, y square less than delta square, and using 4 and 3 you will get tan square x plus tan square y. This is less than or equal to x square by 1 minus x square plus y square by 1 minus y square less than or equal to delta square by 1 minus delta square plus delta square by 1 minus delta square. So 2 delta square by 1 minus delta square. Now you consider, because it is just a sum of 2, assuming delta 1 equal to delta square, we get tan square x plus tan square y less than or equal to 2 delta 1 by 1 minus delta 1. Now for any given epsilon greater than 0, you will find delta 1 from the relation 2 delta 1 by 1 minus delta 1 equal to epsilon. So delta 1 will give you epsilon by 2 by 2 plus epsilon, and then delta by the relation delta square equal to delta 1. So for this reason delta equal to square root of delta 1. So that means delta equal to square root of epsilon by 2 plus epsilon. Then you can get that fxy minus f00, this is equal to tan square x plus tan square y less than or equal to x square by 1 minus x square plus y square by 1 minus y square. This is less than or equal to 2 delta square by 1 minus delta square less than epsilon. Here is this epsilon. So norm of xy minus 0 0, that means this Euclidean norm, this is less than delta, and hence fxy is continuous at 0 comma 0. I am just those who are watching the video, you will just watch the video in the YouTube, you pause them and you can, it is clearly written, so that will be not very much problematic for you to follow the proof. Next, where is the function fxy equal to x square minus y square by x square plus y square is continuous. For the function of type pxy by qxy, where pxy comma qxy are continuous, such functions are continuous on all the points where qxy not equals to 0. In our case, qxy equal to x square plus y square and qxy not equals to 0, and for xy not equals to 0 comma 0, this function fxy is continuous on all the points except 0, 0. So for the function of the type pxy by qxy, where pxy, qxy are continuous, such functions are continuous on all the points where qxy not equals to 0. In our case, qxy equal to x square plus y square, and qxy not equals to 0, because here we are using just quotient rule. Xy not equals to 0, 0. Thus function fxy is continuous on all the points except 0, 0. So we get our answer. So now we need to check on 0, 0. So for point xy equal to 0, 0, rest of the points we have proved that this function is not continuous. Now we have to show that at 0, 0 the function is not continuous. So for the point x, y equal to 0, 0, we use y equal to mx relation. Then fxy equal to x square minus m square x square by x square plus m square plus x square. This becomes 1 minus m square by 1 plus m square. Now as limit fxy as xy tends to 0, 0 depend upon m, for different values of m, we get different limit of fxy as xy tends to 0, 0. Hence fxy is not continuous at 0, 0. So I am putting this proof for your convenience. Just a couple of minutes, you just write down the proof quickly. So this y equal to mx functional form and y equal to mx square functional form, it will be very useful throughout function of limit of 2, limit continuity of 2 variable calculus. I am just keeping this proof for your kind attention. Are there any here? There are not much interesting proofs here. Here maybe some good amount of notes. I think Professor Anuj Jhakar's note you can also use. You can have a look on these notes of Anuj Jhakar. See, this is a note that is properly from Professor Anuj Jhakar of IIT Madras. These notes also very good of Professor Anuj Jhakar. I will use this note and I will upload this note in your NPTEL in our NPTEL PDF. It will also be very useful. Functions of several variables, lecture 2 by Professor Anuj Jhakar of IIT Madras. So limits of functions of 2 variables, already we have discussed this. I will discuss this note also. First let me finish, then I will also discharge generalization. I will upload this note. I just, because this note is very quality note. See, everything is written here clearly. I will upload this note. Okay, this note is also very fine note. I will upload this note. So this is a problem which you need to solve on your own. Question: determine the set of points at which function is continuous. A. fxy equal to x square minus y square by x square plus y square if xy not equals to 0, 0 and equal to 0 if xy equal to 0, 0. So fxy equal to 3x square y by x square plus y square if xy not equals to 0, 0 and this is equal to 0 is if xy equals to 0, 0. Okay, just note down the questions. I will upload Professor Jhakar's note also. Okay, Anuj Jhakar notes. Anuj Jhakar notes. So upload it. Jhakar calculus note. Okay, next move to the next problem. So problem 6 is solution fxy equal to 3x square y by x square plus y square for xy not equals to 0, 0 and f0, 0 equals to 0 for the function of type fxy by pxy by qxy where pxy, qxy are continuous. Such functions are continuous on all the points where qxy not equals to 0. In our case, qxy equal to x square plus y square and qxy not equals to 0 and xy not equals to 0, 0. Thus function fxy is continuous on all the points except 0, 0. We have to check on 0, 0. For that we will use polar coordinates. So how to use polar coordinate? X equal to r cos theta, y equal to r sin theta. So x square plus r y square becomes r square. Norm of x square x comma y less minus 0, 0 equal to x square plus y square equal to r square. Hence x comma y tends to 0, 0 if and only if r tends to 0. Okay, so next okay, so now limit xy tends to 0 0, fxy equal to limit r tends to 0, 3 r square cos square theta into r sin theta divided by r square. This is equals to limit r tends to 0, 3 r cube cos square theta sin theta by r square. So limit xy tends to 0 0, fxy equal to limit r tends to 0, 3 r square cos square theta r sin theta by r square, 3 r cube cos square theta by into sin theta by r square, r tends to 0 by r square. So 3 r cos square theta into sin theta equal to 0. This is equals to f0 0. Hence fxy is continuous at 0 0 also. Next, prove that there is a number delta greater than 0 such that if x square plus y square less than delta square, then x square then fxy equal to x square. So first think about it. Prove that there is a number delta greater than 0 such that x square plus y square less than delta square, then x square plus y square plus 3xy plus 180 x y की power 5 is less than 1 by 10,000. So solution, let fxy equal to x square plus y square plus 3xy plus 180 xy की power 5, f00 equal to 0 square plus 3 into 0 comma 0 into 0 plus 180 0 into 0 की power 5 equal to 0. Now as fxy is just a polynomial function, so it is continuous. So set epsilon equal to 1 by 10,000. So as this function is continuous, hence for this epsilon equal to 1 by 10,000, there exists a delta greater than 0 such that norm of xy minus 0 0 less than delta. This will give you mod of fxy minus f00 less than 1 by 10,000. So square root of x square plus y square less than delta. This will give you x square plus y square plus 3xy plus 180 xy की power 5 minus 0. This is as equal to 1 by 10,000. So x square plus y square less than delta square. This will give you x square plus y square plus 3xy plus 180 xy5 under mod less than or equal to 1 by 10,000. So if thus there exists a delta greater than 0 such that x square plus y square less than delta square, then there exists some x square plus y square plus 3xy plus 180 xy की power 5 less than 1 by 10,000. Can sin of x plus y by x plus y be made continuous by suitable defining it at 0, 0? At first look, it looked like by defining f00 equal to 1. We can make it so. As it looked like by defining f00 equal to 1, we can make it continuous, as we know very well that limit t tends to 0 sin t by t equal to 1. But that is not the case here. If possible, let define f00 equal to m, where m is any real number. Here main point to note is that given function sin x plus y by x plus y is not only have problem at 0 0, but on the whole line x minus x belongs to R. So even after defining f00 equal to m, limit xy tends to 0 0 sin x plus y by x plus y does not exist, because when we try to take limit by the path y equal to mx for m equal to minus 1, limit does not exist, as sin xy x plus y by x plus y does not depend on this line. But yes, we can define sin x plus y by x plus y on the whole line x minus x equals to R, then we can make this function sin x plus y by x plus y continuous, because the problem is not here at sin x, the problem is not here at sin t by t, the problem is here at x plus y. So what is your answer? So this cannot made be continuous by defining it 0, 0, because the problem here at x plus the line x plus y equal to 0. So if we suitably define at x plus y this line, then we can have make this function continuous. Is it clear? So can sin x plus y by x plus y be made continuous by suitably defining it at 0, 0? So the answer is yes. No. Okay. So in today's class I have basically discussed, this note is already uploaded in my class, this Google Classroom, in my this portal. Here it is the week 2 note.
উদয়বাবু কাজ যাবে নাকি? উদয়বাবু বলছি, উদয়বাবু কাজ যাবে নাকি? কালকে সোমবার বলুন সবাই তো কালকে বলুন একটু জায়গা বলুন বলুন আমরা একসঙ্গে করবো ঠিক আছে, কিন্তু এই সমস্যা একটা দরখাস্ত দেবে
I will start some questions here.
জানি স্যার দেবে জানি, কিন্তু আমার মধ্যে একটা করে দরকার একটা আলাদা একসঙ্গে থাকবো ঠিক আছে, ওটা একটা হচ্ছে, কিন্তু আমাদের ব্রোকারটা হোক না আলাদা, ওটা তো হচ্ছে আমাদের ব্রোকারের যেটা হচ্ছে একটা আলাদা। বলছিলাম দুশো আশি ওই লক্ষ্যটা
Okay, there is also an interesting problem here. This type of problem we can easily solve. That limit x find the limit 3xy by 3x square plus y square. See, whenever the degree of the numerator and the denominator are same, there is a very chance that it will not, the limit will not exist. So y equal to mx if you put, so it becomes 3mx square plus 3x square plus m square. 3m by 3 plus m square equal to, that means 3m by 3 plus m square. So if you take m equal to 0, you will get 0, m equal to 1, 3 by 4. Now find the limit xy cube cos cube by 2x square y cube, or show that limit does not exist. How you will show that? For x equals to 0 along y axis, limit xy cube cos x by 2x square plus y cube cos x, if you put x equals to 0, so that becomes 0. That means you are moving along y axis. Now take x equal to y cube. If you take x equal to y cube, here it becomes y cube power 6 cos y cube, 2y cube power 6 y cube power 6. So cos y cube y6 will gone. So this will become y6 will cut down. So cos y cube by 2 plus 1, so that means 3y cube power 6. So that means cos 0 is 0, so 1 by 3. So therefore the limit does not exist, because you can see that along two paths your limits are not giving you equal results. Again another good question. Find that limit 2xy minus 2y by x square plus y square minus 2x plus 1, or show that the limit does not exist. Force x equal to 1 and move along y axis. So limit 2y minus 2y equal to 0. So 1 plus y square minus 2 plus 1. So it will give you 0. You are putting x equal to, forcing x equal to 1. Now move along x equal to y plus 1. So if you move along x equal to y plus 1 or y equal to x minus 1, so you notice that 1 comma 0 is lying on that path. So 2xy minus 2y by x square plus y square minus 2x plus 1, this give you limit xy tends to 0 0, 2y plus 1 y minus 2y. by y plus 1 whole square plus y square minus 2y plus 1 plus 1. This will give you xy tends to 0 comma 0 limit 2y square plus 2y minus 2y by 2y square xy tends to 0 0. Therefore the limit does not exist. There are ways to calculate the limit of multi variable functions instead of trying to prove that the limit does not exist. If you see a lot of terms of x cube, y cube, x square, y square, you might be able to convert xy in Cartesian coordinate system to polar coordinates. X square plus y square equal to r square, x equal to r cos theta, y equal to r sin theta. So find that limit x cube plus y cube by x square plus y square, xy tends to 0 0, or prove that the limit does not exist. Limit xy tends to 0 0, x cube plus y cube by x square plus y square equal to limit r cube cos cube theta plus r cube sin cube theta by r square cos square theta plus r square sin square theta equal to limit r tends to 0, r cube sin cube theta plus cos cube theta by r square. So limit r tends to 0 plus r sin cube theta plus cos cube theta equal to 0. So the limit does not exist and is equal to phi. So limit and continuity, find that limit x square plus y square ln x square plus y square, or prove that limit does not exist as xy tends to 0 comma 0. So x square plus y square equals to r square, limit x square plus y square ln x square plus y square. So limit r tends to 0 plus r square ln r square. So that becomes 0 into minus infinity. So this is a indeterminate form of 0 into infinity. So you can use L'Hopital's rule. So you write it as ln r square by 1 by r square. So use L'Hopital's rule. It will give you limit r tends to 0 plus 2r by r square, and this becomes 1 by r square का क्या आएगा, 1 by r square का आएगा, oh okay, so 1 by r square इन्होंने u, it broke like u and v and all, so it will be minus 2 by r cube, minus 2 by r cube. Now if you just multiply it and make some calculation, you will get it as there is a bit you will get it as limit r tends to 0 plus 2r5 minus 2r cube. So you will get it as, so here you will get just minus 2r cube or 5 by minus 2r cube, it will be 0. So there are also some problem. So sometimes we can use the concept of continuity for proving that the limit exists and hence obtain the value of the limit. If we have a region, two-dimensional region in xy plane, that the function is defined in that region, the function is continuous in that region. In other words, a function is continuous at any point inside the domain. See, if we have a region, two-dimensional region in xy plane, that the function is defined in that region, the function is continuous in that region. In other words, the function is a continuous at any point inside its domain. Polynomials are continuous everywhere. Rational functions are continuous everywhere except where the denominator is 0. We have already discussed it. So fxy equal to x cube plus xy plus y cube. So except it to prove is you can see limit does not exist, you need to show fxy equal to x cube plus xy plus y cube is continuous everywhere in R2, therefore the limit exists and is equal to the value of the function of the point. So f01 equal to 0 plus 0 plus 1 by 0 plus 1 plus 1, because x square plus y square plus 1 cannot vanish anywhere. Investigate the contingent fxy equal to square root of x e की power xy, x greater than or equal to 0, under the square root we cannot have a negative number, and y not equal to 0 because then e की power xy blows up and goes to infinity. So continuity is you need to have x positive and y should not be equals to 0. So this is squeeze theorem. Okay, but this is definitely of your syllabus, so okay, so this is just an you can use it is just you can use polar coordinate also. Use x equal to r cos theta, y equal to r sin theta. I also use squeeze theorem. So squeeze theorem we have already discussed in the first. So 0 less than or equal to x square plus y square less than or equal to 1. We know that 0 less than or equal to 5x square by x square plus y square. This is less than or equal to 5. So this will imply that 0 less than or equal to 5x square mod y by x square plus y square less than or equal to 5 mod y. So note we cannot multiply the inequality by y, because if y less than 0 then the direction of inequality signs changes. So we multiply it by mod y. So 0 less than or equal to 5x square mod y by x square plus y square less than or equal to 5 mod y. This type of problem I have already discussed in my with the very beginning. So limit xy tends to 0 0, this becomes 0. This 5 mod y, xy tends to 0 0, this becomes 0. So by squeeze theorem 5x square y by x square plus y square equals to 0, xy tends to 0 comma 0. So far we have proved that limit x comma y tends to 0 comma 0 mod of 5x square y by x square plus y square 0. But we are after limit xy tends to 0 comma 0 5x square y by x square plus y square 0 comma 0. So you remember the limit of composite functions theorem. If g is continuous and f is continuous at ga, then limit x tends to x comma a is f of gx, limit that you can actually, if f and g if g is continuous at a and f is continuous at ga, then you can shift the limit inside the function. So now limit of xy tends to 0 comma 0 5x square y by x square plus y square, this is equals to 0. You take the limit inside, limit xy tends to 0 5x square y by x square plus y square 0 comma 0, this will give you 0. So then limit x tends to y 5x square y by 0 comma 0, this is equals to 0. So very less people joined in today's class.